All right, this is section 4.4, and we are just going to dive right into the problems. And the first one is an expand problem. And so we have the ln, and then we have a set of parentheses, and we have x to the 8th, and the square root of p to the 7th q. And that's being divided by e to the 9th. And so since this is an expand problem, we're going to take a look and we're going to say, okay, well, we know multiplication is happening here, but also here. And we know that when we have a square root, there's a teeny tiny 2 here. And since there's already a 7 here, I'm good there, but this is technically being raised to the first. And so the first thing that I'm going to do is I'm going to go ahead and expand that. So I'm going to say, well, it's x to the 8th. That hasn't changed. Multiplication sign. Remember how we talked about x to the 1/2 is the square root of x? Well, we're going to take that and we're going to go in reverse. We're going to say that the square root of p to the 7th is really going to be p to the 7/2, multiplication sign, and q to the first, the square root of q to the first, rather, is going to be q to the 1/2. And then for the time being, e to the 9th stays the same. Okay, and so now again, just like I did in the notes, we're not going to look back at this guy. Okay, so we're focusing on this new one. This is a 9, by the way. Okay, and so then we also know that when we have a power, so this guy and this guy and this guy and this guy, when they're up top as exponents, when we go to expand them, they're going to make their way down right in front of our variable. And so what I'm going to do is I'm going to go ahead and do this. So I'm going to say the ln of, and again, when I look at this, I see multiplication, multiplication, and then division. So I'm going to add, and then subtract. And so I'm going to bring down this 2, and I'm going to have, okay, well, hold on, I got to back up. I've messed up. This is not a 2. I don't know what I was thinking. This should be an 8 from the given problem. Sorry. And so I'm going to bring down this 8 in front, and I'm going to have 8 ln of x. And then I have, so this is taken care of, my multiplication, which means I'm going to turn into a plus. And then I have p to the 7/2. Well, I'm going to bring that 7/2 out front. And I'm going to have 7/2 ln of p. And now this is taken care of. And then I see this other multiplication dot, which again means to add. And then I see q to the 1/2. And so 1/2 is going to come out front, the ln of q. And so now this is taken care of. And then I see my division bar, which tells me to subtract. And I'm going to have the ln of e, and that 9 is going to be out front. So I'm going to have 9 ln of e. And just like we talked about in the notes, when we have this, we have the ln of e. Oh, gracious. When we have the ln of e, okay, so this is a side note, the ln of e, we know that is equal to just 1. And the reason why is because it's log base e of e. And if we were to actually rewrite this in exponential form, we would have e to the y equals e to the first. And in that instance, y would be 1. And so what's going to happen is this guy right here is going to turn into just the number 1. And so 9 times 1 is going to be just 9. And so when it's all said and done, I can get rid of all of this. That 9 ln of e is actually going to just turn into a 9. And so my final answer is right here. All right, number 2. This is another expand problem. Okay, and the problem is log base 8 of 64x to the 4th. And so, of course, I look inside and I see that I have multiplication and I see that I have a power. And so since I have multiplication, I know that I'm going to have to add. And since I have a power, I know that something's going to have to come out front. And so this will turn into log base 8 of 64. So that's taken care of. Then I see a multiplication dot, so plus sign. This is an exponent. I'm going to bring it out front first. So plus 4 log base of 8 of x. And now remember, we had said when we had 2 numbers, we're going to pay close attention and say, is there any way for this 8 to be raised up to a power to become 64? The answer to that one is yes. 8 squared is 64. So this entire lot right here will become just the number 2. And then over here, nothing else can change. So I will have 4 log base 8 of x. And this is my final answer. All right, number 3, we did one similar to this in the notes. This is still an expand problem. And we have log, and then I have 1.7. This was the one where we had a multiplication dot, and it looked like an x, but we rewrote it because it's times 10 to the 11th, and that's being divided by x to the negative 7. Okay, so this means times, right, multiplication. And so again, we're going to kind of look at this, and since no log is given to us right here, no base, excuse me, is given to us, we can assume that that's base 10. So if you feel more comfortable putting that in, go right ahead. And so we see that we have a number, we have a multiplication dot, which is going to turn into addition. We have another number that's being raised, which means it has to come down. Then we have a division bar, which means somewhere along the line I have to subtract. And then we see in the bottom another exponent, which is also going to have to come down. So this is going to become log base 10 of 1.7, then my addition sign. And then since I have this exponent, let's bring it out front first. So plus 11 log base 10 of 10. And then I'm going to put my subtraction sign. And then I'm going to jump down here. So here's my subtraction sign, right? And then, hey, look, here's another number. So let me bring it out front. Well, if I'm going to have minus a -7, what happens is this becomes plus. And then I'm going to have log, I'm going to have to rewrite this down here. So minus the -7, that becomes plus 7 log base 10 of x. And so now I have to go through and I have to clean this up the best that I can. And I want to put it back as just 1, and I want to take the base 10 away because I don't really need it. So I'm going to start out with this guy. And so here's my final answer. I'm just going to have log of 1.7. I don't need the base 10 because it's the common log, so it's assumed that it's there. Now, this piece right here, this is a special little guy. On the previous problem, we had log base e of e. We said that was just 1. Well, guess what? Log base 10 of 10 is also just 1. And so we have 11 times 1. That's just going to be plus 11. And then down here, again, I don't need this base 10. Nothing's changing, so plus 7 log of x. And this is my final answer. All right, number 4. We are still doing expanding. Okay, I think there's just a few more. And so the problem is the ln of 3x to the 5th over y to the 8th. And so I look inside of this and I say, hey, look, here's multiplication. This is going to have to come out front. This is going to have to come out front. This is subtraction. So now I'm ready to do it. So I will have the ln of just this number 3, take care of 3. The multiplication dot means I need to add. This 5 is going to come out front, and I'll have 5 ln of x, and this is taken care of. And then my division bar represents a subtraction sign. And then I have this 8, which I'll bring out front. And so I will have 8 ln of y. And then, as always, I have to go back and make sure nothing can simplify. Well, I don't have base 10. I don't have any e's. So guess what? Done. One swift motion, and we have our answer. And now we're done. Okay, so we're going to switch gears, and we're going to do some condensed problems, which we know just work in reverse. So if I start out with the ln of 15 plus 9 ln of x, I have to condense this. Well, the first thing I'm going to see is that I have a plus sign, which I'm going to turn into multiplication. And then I notice that this is a front-running number, which I know must have come from this x. Okay, so that's pretty much all I see. And so this is going to turn into the ln of, and then I'm going to make a set of parentheses here. And let's see, wait a second here. Okay, hold on, I got to go back. There's more to this problem. No, you know what, never mind. Okay, so here we go. We're going to have, excuse me, 15, and we're going to bring this 9, and we're going to have up, and we're going to have 15x to the 9th. And that's it. We condensed it. We took many logs, we made 1 log. Done. Okay, number 6, still a condensed problem. And the problem looks like this. We have the ln of z minus the ln of 19x. Okay, and so as we look at this from left to right, the first thing that we really come across is subtraction sign, which I know I'm going to turn into division. And that's it, right? There's just 2 pieces. That's the only thing that's separating the 2. So I can do this. I can just say, okay, well, this is the ln. The first letter, which is z, is going to come on top. And the second piece, which in this case is 19x, is going to go on the bottom. And that's it. I've taken many and I've made 1. So sometimes it is very straightforward. All right, let's do another one. And by the way, these are straight out of Hawks. Okay, I went through and did a practice section. This is exactly where I got these. So number 7, the ln of z plus the ln of the number 9. Well, again, as I look from left to right, the first thing I see is this addition sign. And really, that's the only thing I see. I don't see any variables out front. I don't see anything else happening. And so I know I'm going to turn this into a multiplication. So that will give me the ln of, in my parentheses, I will have z and 9. And typically we put them in numerical and then alphabetical order. And so the answer for this question is the ln of 9z. Okay, number 8. Excuse me. We're going to have another condensed problem. Break that out, condense. Okay, and the problem is 4 log, in parentheses, x to the third y squared. And then I'm going to have plus 2 log 1 over x. And this is a big one. And then I'm going to have minus 3 log of y. Okay, and so there's my problem. And so as I look from left to right, I see a lot of things happening. I see this front running 4, which tells me that it actually came from right here. And then I see this front running 2, which tells me that it came from right here. And then I see this 3, which tells me that it came from right here. These numbers out front were at one point actually exponents. Okay, and then I see an addition sign, which tells me multiplication. And then I see a subtraction sign, which tells me division. Okay, so I have a lot going on here. So let's do it step by step. So let's start out by saying log. And then, of course, I'm going to have x to the third y squared all raised up to the 4th. And then since I have this plus sign, that means multiplication. And so then this 2 is coming over here, and I'm going to have 1 over x squared. Now, this looks pretty bad. Okay, this looks kind of messy. So we're going to put a set of brackets around this, because technically I'm multiplying this. And then all of that nasty stuff should be divided by y to the third. Okay, well, here's what I'm going to have to do. What I'm going to have to do is take this number 4 and distribute it to each of these little guys, and then take this number 1 and distribute it to each of these little guys. Okay, because that's our power to a power rule. So this is going to turn into log, and then if I have x to the third and I raise it to the 4th, that's x to the 12th. And if I have y to the 2nd and I raise it to the 4th, that's y to the 8th. And then if I have 1 and I square it, so here's my multiplication dots, that's still 1. But if I have x and I square it, well, that's x squared. And this whole thing is still over y to the third. All right, now here's the thing, okay? It looks like I'm seemingly getting closer to being done because technically I've gone from many to 1 log. However, I have some things I got to take care of. I don't want this fraction left over, and plus I have a y on the top and on the bottom. So the last thing I'm going to do here is we know, okay, here's a side note, we know that if we have 1 over x squared, that's actually x to the negative 2. Okay, and we know that if we have x to the negative 2, we have to put it in the bottom, so to speak. And so what I'm going to do is this. I'm actually going to say, you know what, you have to go in the bottom. So here's my x2. Okay, and then I'm going to say, well, look, I have some y values, and I also have some x values, okay, in the top and in the bottom. And we learned way, way back when we did exponents that when we divide, we really subtract. So here's what I'm going to have to do. I'm going to have to take x to the 12, and I'm going to have to minus x2, and that's going to give me x to the 10. And then I'm going to have to take y to the 8th and minus y to the 3, which is going to give me y to the 5. And so what happens is, technically speaking, there's no more bottom. So what I'm left with is x10, y5. And this is my actual complete and final answer. Okay, number 9. Now we are going to evaluate. So this is number 9. We are going to evaluate a problem. And in parentheses, I'm going to put how we're going to do it. We're going to be using change of base. Okay, and so somewhere you have those formulas. And so here's the problem. Log base 4 of 627. And we know that this is our b and this is our x. Excuse me. So that's going to give me log base 627 over log base 4. And I'm going to type this into the calculator. Okay, and you're going to want parentheses around the top, then your division, then parentheses around the bottom, and then enter. Okay, and when we do this, we are going to get approximately, and it's going to ask you to round 2 decimal places, 4.65. And that's it. That's the change of base. Now we're going to do another one just like this, number 10, but this one's going to have some decimals and some fractions so that we don't feel super scared. So evaluate with change of base. And by the way, whenever it is time for the test, it's not going to say change of base. It's just going to say evaluate. And so the problem on this one is log 0.333 log base 1/7 of 0.333. And so we're going to look at this and we're going to say, okay, well, this is my b, this is my x. And so then, of course, I'm going to use the ln here just to prove to you that it doesn't matter, okay? And so I'm going to do on top the ln of 0.333 divided by the ln of 1/7. And again, when you type this into your calculator, you're going to get 0.57. And that's it. We're done. Okay, now number 11 and number 12, I'm actually going to do on the same exact page so that you can see them. But here's what number 11 looks like. And again, I'm trying to solve, or I'm trying to evaluate both of these. Okay, and so the problem looks like this. I have log, and then in parentheses, I have ln, and then in parentheses, I have 730. Okay, well, we've never seen anything like this. Guess what you have to do? Type it in, and that's it. So you'll type log on your calculator. This is what will pop up. Then you'll type the ln button, and then you'll type the number 730, and then you'll close it off with 2 parentheses, and you'll get approximately 0.82, and that's it. Done. This is going to strictly be a calculator problem. We're not going to be able to do this by hand. I don't expect you to do it by hand. Now, on number 12, it's going to be very similar, except the ln portion is coming first. Okay, so we have the ln of the log of 366. And so into my calculator I go, right? Type it in. And so I will first hit the ln button, parenthesis pops up, then I hit the log button, parenthesis pops up, then I type 366, I close it off, and when I hit enter and I do my rounding, I'm going to get approximately 0.94, and that's it, done. So these are pretty easy, pretty straightforward. We just type them on in. All right, now there's only a handful more, and the last ones that we're going to look at are the application problems with the Richter scale and all that. So here is number 13, and it's going to tell you that it's a pH problem. So the first thing that we need to know is that the pH formula is negative log of H3O plus. Okay, now the formula is going to tell you that, or excuse me, the problem rather is going to tell you that the H3O plus is equal to 2.69 times 10 to the negative 12. And they're going to literally just ask you, hey, what's the pH based on this? And so literally all we have to do is take this value, this number, and pop it in right here. And so in my calculator, you're going to type negative log, parenthesis will come up. You will type 2.69. This looks like an X, but it's really multiplication. Multiplication, okay, times 10 to the negative 12. You'll hit enter, you'll round it off to however many decimal points they ask you. In this case, it's just 1, and you should get 11.6 as the pH. And now you're finished. Okay, so 14 is going to be very, well, it's going to be another question, but it's just a type in, it's just a plug error in. So this is a Richter scale problem. And so the first thing we need to know is that the formula for Richter scale is R equals log, and then we have I over I sub 0. And in the problem, it's going to tell you basically that I is equal to, in this case, 10,000. And like I mentioned in the notes, we don't typically have an I sub 0, so we just have to take the log of this number. Literally, take this number, put it right here as a whole. And so you're going to write on your paper, R equals log of 10,000. And you're going to type that in. And in this particular case, it happens to be a nice, neat whole number 4. That may not always be the case, but at this time it is. And so 4 is my answer. I plugged it in, I typed it in, I got 4. Done. All right, so then the last one, the last problem for this section is going to be number 15. It's going to be the decibel scale, which we mentioned earlier measures sound. And so the formula for that is given to us as D equals 10 log, and then we have I on top and I sub 0 on bottom. Now this problem, we do have an I sub 0. And so the problem will tell you that I sub 0, this will be given, is 10 to the negative 12. They'll tell you that. And then they're going to go on to say that maybe a sound is 50 watts. Okay, whatever. They're going to say the sound is 50 watts. So they're, with this information, they're going to say, hey, what is the decibel? And all you're going to have to do is take this given information and plug it into its respective spots. And so you're going to write D equals 10 log. And then on top, you're going to have your 50. And then on bottom, you're going to have your 10 to the negative 12. And then this is what you type in. And when you do that, it's going to ask you to round decibels to the nearest whole number. And so you're going to get 136 point something, but you're going to round it up to 137. And now you're done.